Welcome to lesson number 3. We're going to be looking at the x and y intercepts and interpreting relations. So just a little bit of a review. We looked at a relation, and that's it. A relation is a connection between two different quantities, and it can be represented graphically by a set of ordered pairs. The first component of a set of ordered pairs is the x-coordinate, and that represents the dependent variable. The second set of ordered pairs is the y-coordinate, and independent variable as the first one. The y-coordinate represents the dependent variable. Now, if we were to explore these three different graphs that we have here, I have graph 1, graph 2, graph 3. So graph 1 crosses the x-axis at x is equal to -3 and 0. The x-axis right here. If I look at graph 2, it crosses the x-axis at two spots, at -2 right there, so -2 and 0, but also +3 and 0. If I look at graph 3, this also crosses the x-axis in two spots. We have this spot here, which is at -4 and 0, and +4 and 0. Now, for all of these, what do they all have in common? Well, for all of them, the y-coordinate is 0. So the next thing I'm going to do is list where they cross the y-axis. So if we look back at graph 1, it crosses the y-axis at 0 and 5. Graph 2 crosses the y-axis at 0 and 6. And then graph 3 crosses the y-axis at 2 points at 0 and 4, and at 0 and -4. Now, you might have guessed it by now, but they all have the points 0 in common with the x-axis. So the x-coordinate, if we're looking for the point where they cross the y-axis, the x-coordinate is equal to 0. I encourage you to read this section about the x and y intercepts of a graph, and while you read that, I'd pause the video, and then you can keep playing and watch the next section here. So in class example number 1, the equation of graph 1 on the previous page is 3y is equal to 5x plus 15. Now we want to algebraically determine the values of the x-intercept and the y-intercept of graph 1. So first of all, I would start with my equation. 3y is equal to 5x plus 15. Now, we know that if I'm looking for my x values here, my x-intercepts, then y is going to equal 0. So 3 times 0, if I plug 0 in for y, is equal to 5x plus 15. This will result in 0 is equal to 5x plus 15. If I rearrange to solve for x, I get -15 is equal to 5x. I subtract 15 from both sides, and I divide by 5 to isolate x, and x would equal -3. So the x-intercept is -3. And we can do the same thing for the y-intercept. So 3y is equal to 5 times 0 plus 15. 3y is equal to 15, and y is equal to 5. That means my y-intercept is equal to 5. With graph 3 on the previous page, the equation was x squared plus y squared is equal to 16. And remember, for the x-intercept, y is equal to 0, and for the y-intercept, x is equal to 0. And so we can begin just by replacing my y or my x with 0. So first of all, x squared is equal to 16 if I assume that y is equal to 0. And if I take the square root of both sides of this expression, x is going to give me plus and minus 4. So my x-intercept is equal to plus and minus 4. And I can do the same thing with my y values. So y squared is equal to 16. And if I take the square root of both sides of this expression, then I'm going to get my y values. And this is going to equal, again, plus and minus 4. And so my y-intercept in this case is also equal to plus and minus 4. Next, we have class example number 3, where Lisa purchases a new car for $20,000. The value of the car can be represented by the formula V is equal to 20,000 minus 1,250 times T, where V is the value of the car in dollars and T is the age of the car in years. So we want to begin by completing this table of values. So first of all, where my input is T, so if I were to plug 0 in for this equation T, this is going to become 20,000 minus 0, and so my output here would just be 20,000. That's the value of the car, and which makes sense because she purchases the car for $20,000 and it's not a year old yet. So my ordered pair is going to be 0 and 20,000. Next, when it's 2 years old, I'll plug 2 in here. And so plugging 2 into my expression here, we're going to have 20,000 minus 1,250 times 2. And so my next input is going to be 17,500 if I plug this in by 2. So 20,000 minus 1,250 times 2. And my ordered pair here is going to be 2 and $17,500. Next, if I plug 4 in for T, I'll have 20,000 minus 1,250 times 4. And so 4 is my input value. So minus 5,000, we'd have 1,500. And that's my next ordered pair. And lastly, if we plug 6 in for T, we're going to have 6 and 20,000 minus 1,250 times 6, that would be 12,500 and 12,500. Now we want to connect the points with a straight line, and then we want to extend the line. So what does the ordered pair 0 and 20,000 represent? So this first pair, so this is the time, right? The time in years. So she hasn't had the car for a year yet. So this is the value of the brand new car. So if I use the graph to estimate the t-intercept, what does the t-intercept represent? So if I look at the graph here, oh, sorry, actually we want to connect the points first. So we're going to connect the points first. 0 and 20,000. It's going to be way up here. And then we have 2 and 17,500. So 1, 2, and 17,500. And then we have 4 and 1,500. And then we have 6 and 12,500. So we use the graph to estimate the t-intercept. What does the t-intercept represent? So the t intercept looks like it's right here. So t-intercept is equal to 16. And so after 16 years, the car is worthless. It has no value. So then we want to use the graph to estimate the value of the car after 3 years, after 10 years, and then after 14 years. So after 3 years, so let's see, 0, 1, 2, 3. So at this point, so this is 3 years. At this point, my car was worth about $16,250. At 10 years, let's see what the car was, value of the car, looks like that point there. 10 years, it was about $7,500. And at 14 years, at this point, about $2,500. And then we want to use the formula to verify 2. So at 10 years. So V is equal to 20,000 minus 1,250 times 10. So 20,000 minus 12,500. We would have $7,500. And yes, that verifies. Next, we want to use the graph to estimate when the car will be worth $5,000. So $5,000, again, we can use our graph here. So $5,000 in about 12 years. That's 12. So 12 years, the car will be worth $5,000 and half the purchase price, so $10,000 would be at this point here, and that looks like 8 years. Yeah, 8 years. And then we want to use the formula to verify part 2. All right, so my original formula is V is equal to 20,000 minus 1250t, and we want to know when the car was worth half the purchase price, so $10,000 is equal to 20,000 minus 1250t. So in order to solve and verify for part 2, all we need to do is rearrange and solve for t. So the first thing I'm going to do is going to subtract 20,000 to this side of my expression, and so that's going to leave me with negative 10,000 is equal to negative 1250t. And then I got to divide both sides by negative 1250, so t is going to be equal to negative 10,000 divided by negative 1250, and t is equal to 125, 8 years. So that checks again. Last, complete the following statement to describe the relation. The original value of the car is $20,000, and it depreciates in value by $1,250 per year, and it has no value after 16 years.